Alright, so this is verify. Basically what they're saying is like, hey, are these inverses? So for tables, just find points that are in x and y's are in common. So like this x goes with that one, this one goes with this one, and then see if they match. Well, -3 goes with -8, yay! Positive 3 goes with -14, yay! And those are really the only points I have to compare. I got no other x and y's in common, so I'm going to go ahead and say yes, it is reasonable to assume that these are inverses. All right, number 22, same idea. Let's compare it. So I got no 2's. I got a 4, 5. So 4, 5. Those are good. 6 is 8. I got an 8, 5. Over here I got an 8, 0. Oh, those don't work. So I know for a fact that these are not inverses. Okay, 23 and 24. These ones you can just eyeball them because remember, they reflect across y equals x. They reflect across y equals x. Do not forget this little tidbit. So if I were to draw that line across, I gotta be very careful because I don't have a straight edge. Do they perfectly reflect across that value? The answer is no. You see how it's got this little tick right there? It would have that little tick on the other side as well. Since that's not there, the answer is no. What am I? No, these are not inverses. Alright, 24, same idea. Let's go ahead and draw that little line in. If I take right here, and it cuts right through the middle of that. Let's see, come on, get it right. That, if you turn it, is a perfect mirror image. So this one is a yes. They are inverses. Okay? Basically, you're just checking to see if they're inverses. The next two, let me escape and slide down a little bit. Discard. There we go. Number 25. These ones ask you to just tell me if these are inverses. So the way we do it is we solve. We want to know if I were to solve for the inverse of that, do I get that? Okay? So again, just like before, I'll switch my x and y. Alright, so that's x plus 7 equals 2y squared. I'll divide by 2. X plus 7 over 2 equals y squared. I'll take the square root, so that's plus or minus the square root of x plus 7 over 2. And it turns out that yes, x plus 7 over 2, so yes, these are inverses. 26, just based on elimination, the answer is probably no, but again, let's solve it. X equals -4, y minus 5 squared plus 7. So again, we'll subtract the 7, so that's x minus 7 equals -4. Bring everything else down. Divide by -4, x minus 7 over -4. Equals y minus 5 squared. You can probably see the answer already, but we'll figure this out. Square root both sides, so that's plus or minus the square root of x minus 7 over -4 equals y minus 5. Then add the 5, so that's 5 plus or minus the square root of x minus 7 over -4. And you'll look at this and say, yeah, they're really close, except for the negatives there. Now, here's what I will say. X minus 7 over -4 is the same thing as 7 minus x over 4. But you got to have a negative somewhere. You got to flip your signs, you got to multiply by a -1. All right? So the answer to this one is no, they are not inverses. They are not inverses because they just straight flip these two signs. And you can't do that without having some sort of -1 multiplied or something along those lines. Oops. Alright, so the answer is no. Cool.